Namaste, dear bachcho. Welcome back. My name is Brijesh Mehta and I am your chemistry mentor, right? So, in our previous video, we ended up with defining what is atomic number. Once again, let us recall as it is very important term and then we'll continue from there. So, atomic number is defined as the number of protons inside nucleus of an atom. We have already studied that atom consists of nucleus in its center and there are protons and neutrons in its nucleus. So number of protons inside the nucleus call its atomic number, right? Now atomic number uniquely identifies that element. It means that different elements have different atomic number. If the atomic number changes, then the element itself changes, right? So it is unique for a given element. I'd already asked you to learn names of element till atomic number 20 if you are a 9th or 10th standard student, and till atomic number 30 to 36 if you are 11th standard student, right? So later on you need to remember most of the part of the periodic table, right? So this was atomic number. Now the next term we use is atomic mass number or simply the mass number. The symbol is A, right? Symbol for the atomic number is Z and symbol for the atomic mass number is A. The sum of atomic number, that is the number of protons, and the number of neutrons gives mass number, right? So mass number is number of protons plus number of neutrons inside the nucleus, right? If we say number of boys in the classroom as number of protons, and if we take number of girls in the classroom as the neutron number, then the total strength of the class, that is the sum of boys and girls, gives us the mass number. So this is very simple, right? The sum of atomic number means number of protons, okay, number of protons, and the number of neutrons gives the mass number A of an atom. Since protons and neutrons have approximately the same mass and the mass of electron is negligible for many purposes, the atomic mass of any atom when expressed in, now this term will be defining later on. I'll take the entire video on this, right? So at present you don't need to worry, you just need to know that, see, I have a certain weight. I'm holding this pen, but the weight of pen is negligible as compared to my body weight. So if I weigh myself with or without the pen, then the total weight doesn't change. With the pen, if my weight is 75 kilograms, then without this pen in my hand, my weight would be approximately 75. This is very negligible, this is very light pen as compared to my entire body weight, right? So protons and neutrons have approximately same mass, and electron is a very, very light particle. Proton is approximately 2000 times heavier than an electron. Okay, yes, you heard it correct. Protons and neutrons are approximately I'm saying 2000 times heavier than an electron. Okay, so if you remove electron from an atom, or if you add electron to any atom, the mass doesn't change, right? So mass number is defined as the sum of protons and neutrons. Protons and neutrons have approximately the same mass. Electrons have negligible mass, so we don't consider mass of electron in the total mass of an atom, right? The atomic mass of any atom when expressed in unified atomic mass unit, this is AMU. AMU. Later on we'll define what is AMU, atomic mass unit, is within 1% of whole number of A. This means that if the mass number is 4, then the atomic mass is approximately 4. Mass number of carbon is 12, atomic mass of carbon is also 12. Okay, mass number of calcium is 40, atomic mass of calcium is very close to nearly 40. So within 1% means 99% of 40. 1% plus or minus. Okay, 1% यहाँ से वहाँ होगा तो atomic mass of any atom is very close to atomic mass number. Right? So this we will see later on. So we had studied atomic number is equal to number of protons and atomic mass number is the sum total of protons and neutrons inside the nucleus. Atom primarily consists of protons, neutrons and electrons. Electrons have very negligible mass as compared to protons and neutrons. So the entire mass of an atom is mainly due to protons and neutrons in it, both of which are present inside the nucleus, right? Excuse me, right? So the atomic mass of an atom is due to its nucleus, as the nucleus contains protons and neutrons. Okay. Okay, this is how now we have studied what are symbols, what is atomic number and what is mass number. He stands for helium. Okay, He stands for helium, right? So this is helium, this 2 is atomic number. Atomic number means number of protons. So helium consists of 2 protons and the mass number is 4. This is mass number. Mass number of helium is 4. Now mass number is sum of protons and neutrons. Sum of protons and neutrons is mass number. So if the number of protons is equal to 2 and the sum total of protons and neutrons are 4, then how will you get the number of neutrons? Very simple. If I give you total strength of the class and also tell you the number of boys inside the class, then how you will get number of girls inside the class? Very simple. You just subtract the number of boys from the total number of students. अगर मैं आपको टोटल स्ट्रेंथ क्लास की बता देता हूं और उसमें कितने बॉयज है वो बता देता हूं तो नंबर ऑफ गर्ल्स कैसे मिलेगा? टोटल स्ट्रेंथ माइनस number of boys, right? So in this case, number of neutrons is equal to atomic mass number minus atomic number. Atomic mass number is 4, atomic number is 2, so the difference is also 2. So helium atom consists of 2 protons, 2 neutrons, and as discussed previously, atoms are electrically neutral. Atoms are electrically neutral. Atoms have no overall charge. Protons carry positive charge and electrons carry negative charge. In an atom, number of protons are always equal to number of electrons. So as helium consists of 2 protons, it also has 2 electrons, right? So let us take one more example. Suppose if I give you carbon, atomic number of carbon we write here, it is 6, and mass number of carbon is 12, we write here. So carbon consists of 6 protons. Carbon consists of 6 protons, and as we have 6 protons, we also have 6 electrons, and mass number is 12. Mass number is 12. The sum total of protons and neutrons is 12. So from this we'll get the neutrons, and number of neutrons is mass number minus atomic number. And this also gives us 6. Okay, so carbon has 6 protons, 6 neutrons and 6 electrons, right? So suppose I take one atom, one element which has different number of protons and neutrons. So suppose if I give you phosphorus, phosphorus 15, 31. So 15 is atomic number. 15 stands for atomic number. 31 stands for atomic mass number. Atomic number gives us number of protons. So we have 15 protons in the nucleus of phosphorus. Mass number is sum of protons and neutrons. So we have 31 total of protons and neutrons. So from this we can get number of neutrons, and number of neutrons equal to 31 minus 15, which is 16. So 16 neutrons. And as atom is electrically neutral, number of electrons are same as number of protons, which is 15. So phosphorus consists of 15 electrons as well, right? So in 9th standard, you can be asked this sort of questions, right? Now there is one more important term to be discussed, and that is isotopes. Isotopes, right? Isotopes are atoms with same atomic number. Same atomic number means these atoms belong to same element. As we have discussed previously, that atomic number uniquely defines an element, identifies an element. Different elements have different atomic number. So atoms with same atomic number but different neutrons, different neutron numbers. So this is there in the nature. We found this, that there are atoms with same number of protons but they have different number of neutrons. So we can have 2-3 different classrooms where the number of boys are same but the number of girls differ. So the total strength also differs, right? So let us take one example. Carbon 12, carbon 13 and carbon 14. So when I write carbon, atomic number is always 6. So in the nature, we find these 3 types of carbon atoms. Okay, when I say carbon, atomic number is 6, means 6 protons. But the mass number is 12, 13 and 14, right? So carbon, you can also write like this, carbon 12. So carbon 12 consists of 6 protons. As I have written carbon, atomic number is 6, so 6 protons, and 12 minus 6, the mass number minus atomic number gives number of neutrons. So carbon 12 consists of 6 protons and 6 neutrons. 6 protons and 6 neutrons. Carbon 13 consists of 6 protons, because this is also one variety of atom, carbon, 6 protons, but it has one additional neutron as compared to carbon 12. So here we have 7 neutrons, and carbon 14 has 6 protons and 8 neutrons. This mass number minus atomic number gives number of neutrons. So carbon 12, carbon 13 and carbon 14 are said to be isotopes of carbon. One more example. Hydrogen 1, 1, hydrogen 1, 2. You can also write this symbol, this is deuterium. You can write H12 or you can write D12. And then we have tritium 1, 3. Okay, so these are 3 different isotopes of hydrogen. The first one is called protium. This is called deuterium. And the third variety is called tritium. Okay, so H11, the most common isotope of hydrogen is protium. Most of the hydrogen atoms in nature are protium. So its atomic number is 1 and mass number is 1. If I say we have 1 boy in the classroom and the total strength is also 1, that means we have no girls, right? So 1 minus 1 is 0. So protium consists of 1 proton and no neutrons. This is the only atom in the universe that has no neutrons in it, right? Deuterium consists of 1 proton and 1 neutron, whereas tritium consists of 1 proton and it has 2 neutrons in it, right? So hope you have understood this thing, what are isotopes. So atoms with same atomic number but different neutron numbers and hence different mass number. As the number of neutrons are different, mass numbers are also different, are known as isotopes. A little more than 3/4 of naturally occurring elements exist as mixture of isotopes. Now most of the elements have isotopes, okay? Most of the elements in nature has isotopes, means different types of atoms. And the average atomic mass of an isotopic mixture of an element determines the element's standard atomic weight. We are going to make a video later on atomic weight. So I'm not discussing this thing in detail, right? So you've studied averages in mathematics, okay, in lower standards. You know what is an average, mean or average. So if we have boys and girls with different mass with different weights in the classroom, and if I want to have one representative weight of the classroom, then it should be the average. Like in your result, you have many subjects, in each of the subject you score different marks. Then when someone asks you what are your percentage, you say the average, right? So similarly, isotopes have different mass number and hence different weight. Isotopes have different mass number and hence they have different masses, different weights. So when we represent atomic mass of carbon, it is average of these isotopes, right? So isotopes are variants of a particular chemical element. Carbon is one element and these are the variety of carbon atoms in nature which differ in neutron number and hence in nucleon number. Nucleon means sum total of protons and neutrons. This is called nucleons. The particles present in the nucleus are called nucleons. All isotope of given element have the same number of protons but they have different number of neutrons in each atom, right? Hopefully you have understood what are isotopes. There are similar terms called isobars that we'll see in our next class. Thanks for watching the video. Do join us for many such videos. Hope you are enjoying the classes.